Welcome to Brain Vision.
Okay. So we're calculating the amount of heat removed from a sample of water, which is initial at a temperature of 18 degrees Celsius. Okay. Now, the purpose of us removing the heat is to cool it down all the way to 0 degrees Celsius. Now, basically, 0 degrees Celsius is obviously the freezing point of water. Okay. So in this solution, when we are talking of temperature taken out, or heat energy taken out of water, we will also have to talk about the change of state. That is the change from liquid state to a solid state. Because at the temperature of 0 degrees Celsius, water tends to freeze. All right. So in looking out for our equation to use, we are going to use an equation. We'll say that the heat energy that has to be taken out from water, Q, the heat energy Q, is equal to negative mc delta T. The negative implies that we are removing heat from water plus mLF, okay, mLF, meaning that the change of state, at this point, we'll be talking about the change of state from water to solid, or from water to ice. All right. Now, what is the mass of water? Now, the mass of water, let's say M into bracket H2O, standing for water, is equal to 0.350 kilograms. And then the temperature of water, is equal to 18 degrees Celsius. All right. Now, the final temperature that we'll be looking at is the 0 degrees Celsius, which is the freezing point. Okay. Which is the freezing point. 0 degrees Celsius. All right. So using this equation, let's move on. So the negative indicates heat loss. Okay. The negative indicates heat loss. So we can put the negative aside and still work with our values. So we'll say Q is equal to negative into bracket 0.350 multiplied by 4190 into bracket 0 minus 18, okay, plus 0.350 multiplied by the latent heat of fusion. The latent heat of fusion of ice or water is giving us 334 times 10 to the power 3. You can look up for these constants in your textbooks. Okay, they are constants normally given in most of the textbooks that we have. Okay, so when we follow this, this should give us about 26397 joules plus 16900 joules. So when you put them together, they should give you about 143,297. Now don't forget, the negative sign is outside of the bracket, okay? The negative sign is outside the bracket, so we should always take note of that. The negative sign is outside. So with the negative sign telling us that heat is lost from the system, so this is the energy that has to be taken out if we are to reduce the temperature all the way down to 0 degrees. This is the heat energy taken out of the system. Now, let's convert this energy to calories. Okay, 1 calorie is equivalent to 4.184 joules. So if we are considering 143,297 joules, what would that be? Times 1 calorie or divided by 4.184 joules. Okay, then when we do that, this should give you about 3, 4, 225 calories. So writing it in terms of calories, this is the value. Now let's look at writing it in British thermal unit, BTU. Okay, so we know that 1 joule is equivalent to 0.00947 Now, these factors of conversion can be looked up from most textbooks or from online. All right. So if we have 143,297 joules, okay, we are converting it to BTU. So what would that be? So we have 143,297 times 0.000947817, all divided by 1 joule. Okay, so this joule cancels the joule. Then we are left with a BTU. Okay, all right. So when we multiply that, then that should give us 132. Sorry, forgive me. 135.82 BTU. So in British units, this is what we have.